Several people asked about vocabulary. That was a pretty consistent request. And I had, I think, more than one person ask about combinations questions. And combinations and probability tend to go hand in hand, so we have some of those as well. And so we'll do sort of like maybe 20 minutes discussing vocabulary and verbal studies, and then 40 minutes working through some probability and combinatorics ideas. But in the meantime, I'd like to ask the room first before we do anything else. But type in the chat window, how do you study vocabulary? Like, what are the actual physical mechanics of your vocabulary studies? I'll give everybody a moment to respond in the chat. Flashcards is very popular because it is very time efficient. Do we have anyone in the room who's doing something that's not based around flashcards? Games, yeah, nice. Has anyone tried making, downloading a quiz app of some type? And plugging the words into some type of quiz app? So flashcards is where pretty much everybody starts. Arjun, I've heard of, I think the two that I've heard of, I think they're called Kahoot and Quizlet. And you can use them to design your own quizzes. And from what I understand, at least one of them, if not both of them, you can sort of make it sort of randomized quiz questions.
Okay.
And, it can just pop up random vocabulary quizzes for you based on the words that you've flagged and put in the program. Alejandra, can you get on the microphone and you say you do sentences? Can you describe the sentences? What makes a good sentence for you?
For me, what I do is try to understand the word and its meaning, and then try to make the sentence according to something that reminds me of someone I know.
Okay. So if it's a very negative or insulting word,
Sometimes.
I suppose that could be interesting if somebody found your study notes, but hopefully they would accept your explanation. All right. So let me share screen here and Myrtle, you mentioned practice test questions that you get wrong. That is where most people begin their work. They start by just looking at questions they get wrong, either in homework or in practice test questions. They go, oh my God, I need to study the vocabulary. I don't want you to start there. Step
Okay.
0. Start with the official guide. Grab the official guide to the GRE. Take every single page in every chapter that has sample verbal questions, reading comprehension, or text completion, or sentence equivalence, any verbal question, and scan those pages. Like visual, I'm not talking about like put it in a scanner and make a copy. Like just visually scan those pages. Any word, anywhere on any page. Now again, this is not restricted to just answer choices and text completion and sentence equivalence. Words inside the sentence themselves, words inside reading comprehension passages, any word, anywhere on any page that you cannot name a synonym for goes on your personal list. Always start with the official guide because that is literally the people making the test telling you, hey, we have used this word in the past and there's a pretty good chance we would use it in the future. So begin there. The really difficult part about this is going to be the level of self-honesty when you don't know the word. It's pretty common when I'm teaching a class. We'll work through a problem and we'll solve the problem, and somebody will say, Chris, by the way, what does this word mean? And I'll say something like, oh, well, that word in this context, it means sort of like blah, 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 blah. And then we'll move on. And 5 minutes later, I'll stop the class and I go, is anybody going to call me on my crap? You said, Chris, what does this word mean? And I could not give you a synonym. I don't know that word. I need to go look it up. And then we'll go look it up, find a synonym. But it's difficult to be honest with yourself when that actually happens. A lot of people have this idea of you read the sentence and you see the word and you're like, you can sort of in context figure out sort of what the word means. But if you don't have a synonym, you don't have the word. So that's the difficult part about this, being honest when you don't have the actual synonym for the word. When you have your list, and you can supplement your list with Manhattan Prep lists, any other list really. When you have your list, begin studying those words. One thing I'm going to caution is say, like any other lists really. I was working with a tutoring student recently who said that he was working with a list that had, I think, like 3,000 words. I'm like, well, at that point, you're basically just trying to memorize the dictionary. 3,000 words is too much. 500, maybe 1,000, but really more like 500 to 600 is where you should be leaning. Because you want to be shooting for things where you've got a list of words which have been sort of planned out enough where it's more likely to be on the list. Um, the other thing to make aware of on your list here is don't bother with jargon or field specific, like, or professional field terms. For example, medical terms, anything like that. Um, the GRE is not going to be testing you on terms that are related specifically that are for like a biological science thing, right? So don't worry about those types of words. When you have these words on your list, begin studying. There are two ways that I recommend studying. Choose one. The first, I suspect, is more effective, but it is more time consuming. Write stories. Best if you write one long story over the course of several weeks, if not your entire time of study. Each day is a continuation of the story. Now, your goal is to 10 words every day in 6 or fewer sentences. Most questions on the test involve multiple words in multiple sentences. Even if it's a one blank text completion, it's still fairly likely that elsewhere in the text completion sentence are vocabulary words that you would need to know. So 10 words every day in 6 or fewer sentences. You're really trying to get multiple words per sentence. Any words you cannot use that day get held to the next day. The next day, choose enough new words that you have a list of 10. Again, have a list of 10. Any questions about the mechanics of doing like a story writing exercise as vocabulary? I had a student once who told me that he started writing a space opera, think like Star Wars or Battlestar Galactica kind of thing. I'm like, that's awesome.
So a quick
I'm all in on
question
that.
about
Yeah.
the stories. So you say 10 words. The 10 words are from the list. It doesn't
Mhm.
have to be like it's not including filler words like the or just
No, as in
any other
like,
word.
yeah, as in like you have 10 words from your list that are vocabulary words you want to study, and you're trying to use those 10 vocabulary words in 6 or fewer sentences.
Okay. Thank you.
So like the actual word count for any day will probably be close to like maybe 100 or 200 because you're writing 10 full sentences. Sorry, 6 full sentences. 6 sentences. Your word count's probably going to be, yeah, 100, 200, I would think. Another question, Ethan?
Oh no, I'm good. Thank you.
Okay. Hmm? Oh, and by the way, Rachel and Megan, the two of you joined in a little bit after I'd started talking. I have given everyone here permission, microphone permissions. So at any point, if anyone, yourself included, have questions, don't feel like you need to, type in the chat, although you can if you want. Feel free to go ahead and just get on the microphone and let me know what you're wondering. So the reason that I think that this method is more effective is because it's generative. You are building your associations for those words and building associations from word to word to word over the course of multiple days. And especially the fact that if a word is held to the next day, some part of your brain is going to be thinking all day long at various points during the day, how am I going to use that word? How am I going to use that word? And you are continuously thinking, and that is going to land the definitions of these words very solidly in your brain. The next way, if you're not going to write stories, and again, like I said, I suspect it's more effective, but it does take longer. Um, make your flashcards, and yeah, flashcards are good. I've got no problem with flashcards. Make your flashcards synonym chains. Um, you've got the word on one side, the definition on the other. Along with maybe stories, maybe images, anything else that you would put on your flashcard. But the main thing is any online dictionary. Oh, and by the way, use an online dictionary, not any type of search engine. Search engines are based on popularity. What shows up most often for the results. The test writers are actually very often trying to use words in less common, sometimes kind of archaic ways. And so make sure you're using a dictionary, not a search engine for this. Any online dictionary will have a list of synonyms for that word that you can click on and look up those words. Click on one. Make sure the definition of this word doesn't stray far from the original. Find a synonym for that word. Click on that synonym, etc., etc., until you have a chain of 3 to 4 synonyms for the word, for the original word. Again, the goal behind this is about generating links. I don't want the words to exist in isolation. I want the words to be linked to other things. That strongly drives more efficient memorization. Yeah, that's that. And then finally, you can also use some kind of quiz app. I was mentioning that earlier. With the words plugged into that. Anyone have follow-up questions about my recommendations for how we study vocab? All
So
right.
one
Yes.
question, sorry, Chris.
Yeah.
regarding the 3 to 4 synonyms that we should be checking, some of them might be quite simple words as well. How many, like, is it more focused on like the synonyms that we usually don't use in the vocab, or we're looking for any synonyms that including those 3 to 4 synonyms?
I would say try to get one very simple word and at least one word that is more GRE like.
Got it.
And Megan, we are going to do some practice problems. I got a lot of requests for vocab, and I got requests about combinations. So we are going to do some practice problems here. I'm not intending tonight to do practice problems on actual text completion or sentence equivalence because, and I've done a few of these. Let me find the date. It was not this one. Was it one of my first ones? Yeah. So back in February of this year, I did a free prep hour that's already on YouTube, where I worked through a lot of text completion and sentence equivalence problems and talked about how to build our predictions. And so my goal tonight was to just talk about the literal mechanics of studying vocabulary, not specific problems from text completion and sentence equivalence, because I've already done that one and it's already on YouTube. So you can go look at that and now you have two separate vocabulary emphasis. And then after we talk a little bit about vocabulary study, we're going to do some combinations and probability work.
Okay, thank you.
Yeah, absolutely. So next. These are the answer choices from 3 different sentence equivalence problems in the Manhattan Prep 5-pound book. I want everyone to take, I don't know, 2 minutes maybe. I'll set up a little stopwatch here so we track and so we don't go too far over. Take 2, maybe 3 of these words. Look them up if you need to. I'll set it for 5 minutes. And then tell me answers in the chat when you have them. Grab 2, maybe 3 of these words, look them up, and put them together into a sentence, and put that sentence in the chat. Let's share some practice sentences with everyone. Everybody take a few minutes. Give that a try. Again, no rush, but whenever you have a sentence, go and throw it in the chat, and we'll talk about what we made. All right, that was 5 minutes. Nice. Getting some fun ones in here. Goodness, these are good. I'm gonna put some up here. All right, I'll put mine there too. Excellent. This is how I'd recommend we study vocabulary. Any questions, comments, concerns? And one of the things I want to point out, there were a few here where I think that where the part of speech as the word is used in the sentence is not correct. Honestly, don't worry over much about that. The test writers will take care of making sure that the grammar usage is correct. You just need to make sure that that the word is put into sentences that give you the meaning and hopefully connect to others. Yeah. All right. Any other comments, thoughts about the mechanics of vocabulary study? If you don't have questions, please just say no questions in the chat and we'll move forward and we'll talk about some probability and combinations problems.
No question.
All right. Beautiful. All right. Well, let's then begin with this problem. It occurred to me that I did not ask at the beginning where we are in our study and preparation for the GRE. Is there anyone in the room who does not know the answer choices for this question type? I'll go ahead and make a note of them here. Always these 4 choices. Everyone take a few moments and type in the chat whenever you're ready. Do you believe quantity A is greater, quantity B is greater? Do you believe the two are equal? Or do you believe that it cannot be determined? All right. Whether you're done or not, I want to bounce to a different problem. Try that problem, and then we're going to discuss how to solve both of them. You will need a calculator for this problem. Everybody try this one. Type in your thoughts in the chat whenever you're ready. All right. What I'd like to ask next is just a feeling question. Everyone type in the chat, what is your confidence level in these problems? Do you feel good about them, or do you feel like you were lost? And I would like a response from everyone, please. Interesting, Ethan. Okay. All right. Well, let's take a step back. Combinatorics. Fair enough, Arjun. I treat combinatorics problems as an application of a formula. There is only one formula. It can be described in two different ways, but there is only one formula. The first way is the more common way. Pool factorial divided by chosen factorial, not chosen factorial. Please notice the parentheses around the chosen and not. Both of those belong in the denominator of that fraction. And we're going to apply both of these to the two problems, so you'll see how these get acted out. Use this phrasing. Again, remember, it's the same formula, just two different ways to describe it. Use this phrasing or description when you have a problem where some things are selected and some things are excluded. The less common, but it definitely can still happen, is pool factorial over repeats factorial. Use this when you are shuffling things into different orders, but everything stays included. So coming back to this first one. Respond in the chat or on microphone. Microphone would be nice as well. Which feels more appropriate for this one? Pool over chosen factorial, not chosen factorial, or pool factorial over repeats factorial?
The
Can you
chosen
repeat
one.
that?
So this problem, which phrasing of the formula feels more natural for this problem? Pool over chosen, not chosen, or pool over repeats?
The first one.
Pool over chosen, not chosen? Does everybody agree? Well,
I would say yes. Yeah, because it doesn't really repeat. If you
exactly.
think about it.
We're not shuffling the coins that we select. We're just selecting some and excluding others. So in quantity A, and again, just on the chat, on the mic, whichever, what is my pool?
56.
I'm choosing 56, but my pool of coins is actually much larger than that.
100.
100. I have a total pool of 100 coins. I'm choosing 56, which means 44 are not chosen. In quantity B, what is my pool of coins?
44.
That's how many I'm choosing.
So is it still 100?
It's still 100. And I'm choosing 44 of them and not choosing 56. And what do we notice about these two fractions?
They suck. No, I'm just joking.
That is a valid response. Would not argue with on that one, but they are identical. And this feels very counterintuitive because everyone's going, how in the hell can choosing 56 out of 100 have the same number of options as you're choosing different numbers of coins? But the mathematics actually works that way because the number of combinations you have is influenced not just by how many you choose, but how many you don't choose. And so the fact that the ones that I choose on one side is the same as the ones that I don't choose on the other side, that's going to lead to two identical results. It's a very weird feeling, but that's the way the math goes. And this is one area where I'm just like, listen, trust the formula. Coming back to this one about the rearrangement of the letters in the word Mississippi.
I got a question.
Yeah, Arjun, yes.
So for this one, so I know, no, for the Mississippi one.
Mississippi one. All right, nice.
So I know that I put 11, but if I turn it into a fraction and take the numbers that I added, I'm sorry if I'm getting ahead of everybody else and everybody, I apologize. But would it be like 34,000 or no?
It's going to be pretty close to 34,000, yeah. I
34,000.
think if I remember correctly, 34,650.
Okay.
Is this one more like pool over chosen, not chosen, or is this pool over repeats? Am I excluding some of these letters or am I just shuffling them?
Shuffling, so it will be repeat.
Repeats. So we use the pool factorial over repeats factorial phrasing. I have 11 total letters. I have one M. I have 4 I's. I have 4 S's. And I have 2 P's. And that's the fraction I use. Now, many, if not any explanation that you'd see for a problem like this would never mention the 1 factorial. And that irritates me a lot. It irritates me for 2 reasons. The first reason, and it's the most fundamental reason, so many discussions and explanations that I see about combinatorics are like, they make it feel like there are 87 different ways that you have to do these problems. And that's not true. It's always this formula. The only thing that changes is that sometimes you have to apply the formula multiple times if you're making multiple choices. Like if I had a problem about, and maybe I'll make this up later, I don't think I have one in there, but a problem about, like, let's say you've got like 10 people and 4 of them are senior associates and 6 of them are junior associates, and I have to pick a group that has 1 senior associate and 2 junior associates. I have to run the formula twice because I'm making 2 different choices. I'm making a choice for the senior associates, and then I'm making a choice for the junior associates. But it's still the same formula. And when you leave out things like the 1 factorial, you're like, well, why doesn't the m get counted? Why do all the letters get counted, but the m doesn't? And it should. It's there. The other reason it bothers me to leave out the 1 factorial is because it leaves out the easiest check to make sure you haven't made a silly mistake. Does 1 plus 4 plus 4 plus 2 equal 11? Do the things in my denominator add up to the thing in my numerator? Do that check, and that's just how I make sure that I haven't miscounted. And when we actually have to do this math, we're going to find out that a lot of stuff cancels. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. 4 factorials are like little Russian nesting dolls. If anybody's familiar with the Russian nesting dolls, like you open the big doll and there's a smaller one inside it. You open that one, there's a smaller one inside it. You open that one, there's a smaller one inside that. Every factorial has the smaller versions of itself inside of it. 1 factorial is just 1. This 4 factorial is going to cancel. The second 4 factorial is 4 times 3 times 2 times 1. And the 2 factorial is just 2 times 1. And so let's see what I can cancel out here. 4 and the 2 will cancel that 8. 3 and the 2 will cancel that 6. And I'll be left with these things. 110 times 9 times 7 times 5. 990 times 35. And that is as far as I could go in my head. And Arjun, did you say 34,650? Because I think that is it. Let me
Yeah,
double check. Yep, 34,650. How are we feeling? Tell me in the chat or tell me in the microphone. How are you feeling now? Arjun, you feeling better?
I feel old, but yes, I feel better.
Alejandra, can you speak up? Why are you feeling a little bit lost still?
Yeah, because the factorial part, I still like trying to making all the multiplication in my head. So for me, it's kind of difficult just to see what is going on here and how to calculate it like fast for the exam.
Oh, yes. I will tell you that most problems, even of this variety, do not use things that are this large. So the level of intensity of just the literal calculations is not very common. A far more common variation would be how many ways can you rearrange? And maybe I can try and spell arrange correctly. Rearrange the letters in the word banana. Ashley, why does 4 factorial pop up twice in the denominator? Every single element gets a place in the denominator. I have 1m, that gets a 1 factorial. I have 4 i's, that's my 4 factorial. I have 4 s's, that's my next 4 factorial. I have 2 p's, that's my 2 factorial. Arjun, what's up?
So I have a question. So why do they ask, how can it be rearranged instead of just asking you to pretty much factor it out? Is it meant to be this confusing, or like, should you already know? Yes.
I'm not sure what you mean when you say factor it out. I'm sorry. Can you give me a
So
little
you
bit
know
more?
how it says, how many different arrangements? So it says in the word wow, right? Can be rearranged in exactly 3 ways, excuse me. So I guess when you think about math and you think about different types of math and the wording and the verbiage, why wouldn't they use something that's more along the lines to let you know that this is something that you need to calculate?
I think, Ardreen, what you're getting to here is the idea that you have to remember what the test writer's goal is. They have several goals. One of them is they don't want to get angry emails from math science majors because they made an indeterminate question that wasn't described in a proper, using a properly definitive mathematical way.
Okay.
And that's what's happening if you dislike a lot of the language in the math problems. The most common example of that is sequence questions. Have you ever seen like S sub n equals like S sub n minus one, blah, 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 that kind of stuff? For all
Yeah, that's
n is greater than
kinda
2. Yeah.
like
That,
coding.
yeah, all of that stuff is so that math science majors don't write them angry emails.
Okay. I get it.
Ashley, this is the combinations formula technically, not the permutations formula. What I find interesting though is that you see lots of reference to permutations versus combinations. It's the same thing. You actually don't need a different formula. I'll make up a problem here in just a moment to illustrate that. Alejandra, can you get on the microphone? Would you be willing to talk through this one? Oh, I can't hear you now. I had audio from you earlier. I'll open up to the group. Should this be pool over chosen, not chosen, or should this be pool over repeats? Anyone in the group speak up?
Can you hear me now? Sorry.
Yes, yes.
Yeah. It will be the same as the last one in Mississippi, right? All over
Yeah.
repeated.
Yes. And what is my pool? How many letters do we have?
6,
How many B's are there?
1,
How many A's?
3,
And how many N's?
2.
Now last check to make sure we haven't made a silly mistake. Does 1 plus 3 plus 2 equal 6? And the answer is yes.
Yeah.
So now we run the factorial until we get to a point where we cancel. And I realize that once I hit the 3, that 3 is a nested 3 factorial inside the larger 6 factorial. 1 factorial is just 1. The 3 factorial is going to cancel. A 2 factorial is just 2. 2 will go into 6 3 times. And so I'll be left with 15 times 4, which is 60. Your answer would be 60. Alejandra, this is actually more like the level of calculation intensity that you would see on most of these problems. Do you feel better about this one? One new message. Good. Okay, good. All right, then let's okay. There are 3 seats left on an airplane, and 6 people want them. How many different combinations can we have of the seated passengers? Everyone take a moment. Type in an answer in the chat when you're ready. Yeah. This is your pool over chosen, not chosen. I have 6 people. 3 of them will be chosen. 3 of them will not. 6 times 5 times 4 times my nested 3 factorial. That will cancel one of the 3 factorials. The other one will be 3 times 2. I don't think it's going to be 120. I don't think it's going to be that many. But we're just left with the 5 times the 4, and it will be 20. Ethan, you got a 120. And in fact, you weren't the only one.
I
Where did
said
the
it.
100?
I
Yeah,
said it.
Ethan, anyone who got a 120, how did the 120, how do we get to 120?
Because you take the way I. Oh, go ahead, Ethan.
Sorry. I thought, basically, I thought like if there are 6 people, and one of them takes a seat, that's 6 seats, and then there are 5 people left, or the second seat, and 4 people for the third seat, and I multiplied that.
And that is the same math as what Ethan put in the chat, 6 factorial divided by 3 factorial. The reason that doesn't work is because that treats all the variations of the 3 people who were not chosen as though they were different variations. When in fact, the people who were not chosen is just you got to divide out the different variations of the not chosen.
So then that would make it like 720 over 36, right?
Maybe I'd have to.
Oh, sorry.
Yeah, I'd
That's
have to.
okay.
Sorry, I would have to grab that. But 720 over 36 sounds right. I'd have to check the math, but that feels right. Let me offer the variation on that. There are 3 seats left on an airplane, but this one's going to be a bit of a twist here. An aisle seat, a window seat, and a middle seat. 6 people want the seats. Again, how many combinations? Everyone take a moment. Give this one a try. Ethan, that's close. You're missing one thing. It's not quite the same as earlier. I'll go and stay on microphone here. What changes here, once these seats are named, they are no longer the same seat. And I have to treat each seat as its own decision. It is still my pool over chosen, not chosen. But I have to address the fact that I'm making multiple choices. I still have 6 people. My first choice will be the window seat, the aisle seat. How many people are going to get that aisle seat?
1.
1. How many people are going to get that window seat? 1. How many people are going to get that middle seat? 1. Now, Ethan, you had this much. What is still needed? There's one more thing.
The other 3
Yes,
people.
we need the not chosen. 6 times 4 times 3 factorial. And I think this one is the 120. 3 times 4. 120. Ashley, it is the same. It is the permutations formula is just a derivation of the combinations formula for specific types of situations. You can run everything through you can run everything through these two formulas. Well, this formula with the two descriptions. The only thing that can get weird about it is a situation like this, where you've got like specific named things, and you have to say each one of those is a specific decision. How many people can get that seat? Whereas here, if the seats are not named, it's just 3 seats, and I don't care who gets which. 3 people are going to get a seat. It is. In this one, the order does matter in terms of like you choose the aisle seat, then the window seat, then the middle seat kind of idea. That's where but uh, for me, it is easier to have one formula that can be applied to every situation than to have a lot of formulas and have to try and figure out which formula to apply. So I run them all through this combinations formula and just think sometimes I'll be making a sequence of decisions. Yes, this is the one formula I use. So let me throw in that other variation of sequence of decisions. It's interesting to me. The questions that I had originally picked out, a lot of them I'm not going to use because the conversation went in a different way. I like that. It's fun. We'll close with this problem. Everyone take a few moments, give this one a try. Ethan, you're trying to run it as though it's one decision. Treat it as 2 separate decisions. I have to choose the senior associate, and then I have to choose the junior associates. All right, let's make our choices. For my senior associate, what is the possible number of choices for my senior associate? My pool is 4. I will be choosing 1. 3 will not be chosen. For my junior associate, my pool is 6. 2 will be chosen. 4 will not. Multiply these together. Always multiply, never add. If you're doing a combinations problem where you need to add things, you shouldn't be doing it. Those things are just way too long. This first one is actually going to cancel out to just 4. The next one will be 6 times 5 times 4 factorial. That's going to cancel that 4 factorial there, and then the 2. 2 will go into 6 3 times, and I'll have 4 times 15. So I'm getting 60. Questions, comments, concerns?
And most of the questions are should we only be multiplying?
Yeah. There are technically situations in a combinations question where you would add certain results, but there are 2 reasons why you should never do those. The first is almost every single one of those instances, if you are adding it, you're adding it because you missed a way to rephrase it into just a multiplication problem. If you basically that happens if you're trying to like calculate the number of failed scenarios and subtract that out from the number of total scenarios. The other reason is just that if you get into a problem where addition is actually required, it's a problem where you're having to do multiple combinations problems over and over and over again to get credit for one problem.
Okay.
How do I know when I need a formula and when you don't? If we're from with first and second place and picking one person per seat out of 5, it's just 5 times 4, no need for a formula. Actually, the formula always exists. When you see an explanation that doesn't use this formula, it's a situation like this, where your 4 factorial over 1 factorial, 3 factorial reduced down to just 4. And explanations don't show that the formula was always there. The reason I like just approaching it from this way is that I never have any inconsistencies in how I'm approaching the problem. Yeah, it's always there. And this is one of the things that bothers me about explanations, because when they just say, oh, well, it's just 5 times 4 times 3 times 2 times 1, and they don't show you where the formula came from, you feel like every single problem has a different approach. It doesn't. The formula is always there.
I have a question.
Yes.
So I did it a little different without putting like the one that shouldn't count. Is that okay? As long as I got the same answer, right?
I mean, fundamentally, the test only cares if you have the correct answer.
Okay.
So if you got a different way, I'm okay with that. My goal for this evening was to come into this with the idea that I wanted to show everyone that one formula is the backbone of every combinations question, and you can run every single combinations question using that one formula.
Sounds good to me.
Plus permutations. Permutations are just like this, where you just say how many people you do the selections in the order. So you would say how many people were chosen for the aisle seat? 1. How many people were chosen for the window seat? 1. That's how permutations run, and it's still the same formula. At least that's the way I do them. All right, my friends. I will leave this page up here for a moment. That is our time for this evening. I believe you all got an email from me. If any of you want a copy of these slides, just let me know over email. I'll be happy to send them your way. In the meantime, this will also be going up on YouTube at some point in time, probably about a month and a half, something like that. Yeah, actually, did you get my email? Did you get an email from me early in the week? I will type my email in the chat just in case.
Well, thank you so much, Chris.
Thank you, Adrian.
This
Yeah,
was amazing.
I'm glad you found it helpful.
Thank you so much. Have a good night.
Yep.
You too, Ethan.
Thanks, Chris.
Bye
Thanks,
bye,
Chris. Bye.
everybody.
Ashley, did you get my email in the chat? Okay. Yeah, just throw me an email. I'll send them your way. All right, have a good night, everybody.